Actually. All right, guys. So let's go ahead and get ourselves kicked off here. I think we'll probably have some really interesting discussion, and folks will filter in as they come along. So first and foremost, I want to just say thanks to everyone for joining us. This is I believe our fifth Innov8. I'm Timothy Summers, resident hacker, ethical hacker, and innovator, and total geek at the University Technology Office at ASU. It's Arizona State University for any international or non-regional attendees. And, I'd like to just, take a moment to thank our esteemed guest, Rob Silverberg, for joining us today. Rob is the Chief Technology Officer of Dell Technologies Digital Communities. Today, he'll be sharing with us about the intersection of smart cities and AI, but specifically, how to make it real. Rob has a rich background with just shy of 20 years at Dell, working closely with communities and governments and helping them design and redesign themselves to embrace the digital in digital communities. A little bit of an interesting fun fact is that Rob sits on the Smart City Advisory Board for Austin, Texas, and San Jose, California, which is pretty fascinating and pretty impressive. So Rob, thanks for joining us today. I'm excited to have you here. The team and I are excited, and we just thank you for spending this time with us today.
Wonderful. Thank you for having me. Very excited to share some of the innovation that goes on within the smart city space. First of all, a couple of sort of terminology things that those who are not familiar with this space probably need to understand. The term smart cities was coined by, I believe it was IBM about 10 years ago. Then about 5 years ago, Cisco jumped in and started calling it smart and connected cities. And lately, as people look at innovation within local government, the general concept is that most of the focus around innovation is labeled smart city. So the market itself has become labeled that. We have our particular strategy and viewpoint when it comes to how we are making cities smarter. And our strategy we call either digital cities or digital communities, because it is applicable to cities, but it's also applicable to counties, state agencies, university campuses, and a lot of the same innovations around technology are applicable at various levels. So I'm excited to have been working on this pretty much full time for the last 5 years. Over that 5 years, I've seen an evolution within the smart city market from experimentations with technology, where certain vendors were trying out innovation and trying out specific solutions to help our government agencies improve. And where it's come to over the last 5 years is now it's more of a mature market. There's real solutions that are proven. And most cities, if they don't have a smart city strategy, are looking to develop one and looking for ways that they can start leveraging technology for improvement. So that's kind of my lead in. I know that there's people on the call. I'm not sure if you're muted or you can talk, but please do leverage the chat window if you have any questions or comments, or if you want to participate in the discussion. As I'm presenting, I'm not really able to see the chat as it comes in, so I'm going to rely upon my my peers here on the panel to let me know that if a question has come in, and I'll try to address it as we go. Don't worry about interrupting me. Interruptions are good, so any questions in line are absolutely fine. And at the end, we should have some time for Q&A and discussion, and I look forward to hearing your feedback. So with that, what I get to do, which was particularly enjoyable, is sit down with our state and local government leaders and talk about how technology can help them improve in various areas. Often this slide I use as I sit down and mention the various, I would say, bigger buckets within the general digital city strategy, whether that's a focus on environment and utility, economic growth, citizen engagement, mobility, public safety, digital government. All these general categories are often parts of a smart city plan or roadmap. Some of the latest work that we've been doing have been in the areas of mobility, looking at reducing traffic and congestion, potentially improving transport and public safety. Some initiatives around Vision Zero. Those of you who may not be familiar with that term, it's the goal that many cities have adopted to reduce the number of accidents and fatalities in their city to as close to zero as possible. Obviously, public safety has been a very big focus lately, not just for protecting the public, but also with the recent health crisis and how to ensure that we can be safer and responsive to the needs of the community. So one other point I'm going to make on this slide is that for sometimes smaller to medium-sized cities, many of the focus areas is around economic growth. They're looking to be perceived as a technology leading agency, and they're starting to put together their smart city strategy with a desire to bring the right type of businesses to their community. So if they are perceived as a technology leading community, they may get the more advanced, I would say, technology oriented companies moving there and fueling their economic growth. A quick pause here in case anyone has any questions or comments on these various areas of focus. Anything in the chat yet, or should we just continue forward?
Nothing yet.
All right, forging ahead. One of the things I've noticed as I've been working on this for the last 5 years or so is that it has become an evolution to outcomes as opposed to experiments with technology. So if you look at smart city technologies, usually it's a combination of connected devices, things that are connected to the internet that are generating new data streams that allow cities or counties to better understand what's happening in their environment, whether that be cameras or traffic sensors or microphones or other sort of connected devices. It's giving them new information and new data. So that's half of the equation, is all the new, what's called Internet of Things or IoT data that's now available, as well as the desire for data analytics and the ability to leverage these data streams both for two primary purposes. One is potentially dashboards and alerts, knowing what's happening in the city, and I'll show you some examples of that. And the other one is big data analytics, things like machine learning algorithms for predictive models. A couple examples on this page that I want to call out. First one is one of the leaders in smart cities, New York City, having done many different smart city initiatives over the years. This is one where they leveraged advanced analytics to predict when certain buildings might fail a fire safety inspection. So leveraging this predictive analytics and historical data, they were able to equip their inspectors with information that helped them identify which facilities, which buildings, and which areas of the buildings are likely to have issues, increasing their efficiency from 13% to 70%. So this is an example of an artificial intelligence called machine learning, which can then predict where these issues are likely to occur. A few of these others are interesting because it's more about that connected devices, things like adaptive traffic signals that can adapt to traffic more readily, speeding commute traffic and other things to various intersections, or something more simplistic like automating waste management. So a trash can now notify the city that it needs to be filled, eliminating the city from having to go empty every trash can in the city when it may or may not need to be filled. So these are the kinds of things that are both Internet of Things related, smart city related, and data related. Some general pillars as I work with cities that are establishing their smart city strategy. Some of the key pillars that they're looking to achieve is greater efficiency within the city, optimized use of resources, whether that's people, businesses, or the environment. Public safety is one of the key things that we rely on our cities to provide. So how can we anticipate risks and protect people and information? Enriching is a goal of that. Most government agencies want to be more interactive with their communities. They want to set up digital government online services, the ability to interact online that will allow them to connect better to their communities. And lastly, for all, there's a lot of discussion around digital inclusion and specific programs and policies that cities are trying to roll out to cross the digital divide and bring connected high-speed internet to all parts of the city that may not be as well connected now. So there's some initiatives across these four pillars that all sort of fall into the smart city bucket and where technology can help the city to improve in these areas. So many of you are probably familiar with artificial intelligence. I looked at the speaker series and there's been a couple of different artificial intelligence related presentations before this one. But a quick concept that will showcase itself in my later presentation is that there's sort of three levels of AI. There's the broad category, all the things that are artificial intelligence. So this is a program that can sense, reason, act, or adapt. Some of the earliest artificial intelligence programs were those designed to play chess. and then refining those chess intelligence and reactivity so that a computer first was able to beat a chess champion many, many years ago, but demonstrating that the right learning tools through artificial intelligence can actually achieve that kind of capability to beat a chess master. You then move into the next level, which is a subset of artificial intelligence called machine learning. This is algorithms whose performance improve as they're exposed to more data over time. So if you think about the concept here of the data that you gather, let's say it's traffic data, and you understand traffic patterns that you're able to generate from your new connected devices, and you're starting to look at that data over time, the more data you have and the more time you have that data, the greater the accuracy of the machine learning models or predictive models. So I'll show you some examples of that, how these machine learning models can help predict what is likely to occur in a certain traffic scenario or people scenario or other scenarios where the system has been able to analyze data over time. The subset of machine learning, which is particularly picking up and becoming very critical part of a smart city strategy, is deep learning. This is a deep learning, which is essentially multi-layered neural networks to learn from vast amounts of data. The primary application of deep learning is in computer vision and allowing an AI to watch a video or listen to an audio stream and determine what's happening in real time. So whether that's counting cars, whether that's anomaly detection, whether that's listening for glass breaking in a parking lot or identifying public safety incidents, these deep learning algorithms can be trained to alert and also to translate video or audio into data. This all comes from a site out there I've referenced because I borrowed it from them called towardsdatascience.com. So if you want to learn more about this, I suggest that site or others similar. Some of the areas that are a big focus in the recent, I would say, months and years is around how these advanced computer vision AIs can enable better intelligence, better situational awareness, and more alerts about what's happening. So in the past, there were these operations control center. This might be an emergency operations center. It might be a traffic monitoring center, typically related to fixed cameras at intersections, limited sensors, basic monitoring. I actually met with one city that actually had people sitting in a room like this, looking at the various cameras across the city, looking to identify incidents as they were occurring and deploy the right response to those incidents. But it was all human-based. Every person had to sit there and the cameras would switch every couple minutes to a different intersection so they could understand what was happening at that time and respond to it. So where this is changing is that now with computer vision watching these video streams, the need for people to watch them is lessened, and the ability for the computers to alert the folks to what's happening, to any incidents that may be occurring, is now being enabled. So if you look at how things are evolving, you can see you've got potentially cameras acting as sensors. We call them optical sensors because that's really what they're doing. They're identifying things and translating that video into data and alerts. Connected devices, body-worn video, audio analytics, mobile video, all these advanced, I would say, AIs are now becoming a key part of a smart city strategy. There's also been a lot of discussion in our cities around privacy, and I think privacy is a very, very important topic. And many of the cities that are deploying these technologies are doing it with an understanding of privacy, the ability to blur people's faces, to not identify specific recognizable attributes. Many of these things are deployed as part of a solution to preserve public safety. Depending on the policy of the government agency, some of them may be more lenient with recording or identifying things, and others may be very restricted from that. And the technologies are adaptable. If you would like to have a greater level of privacy, those are usually policy-based decisions, and the technologies can support it. I noticed the chat blinked. Was there something that someone wanted to ask about? Quick pause.
I think we had someone, I think we had one of the attendees sharing, actually.
Oh, wonderful. Good to hear. So what does it look like? If you deploy one of these systems, often a city will have, say, an existing traffic camera network. That traffic camera network has been in place maybe for several years. They're able to observe video, they're able to record video, but what does the actual artificial intelligence look like? So, should be sending me over to a website with a live streaming feed of what this actually looks like in a live. So this is an example of an AI from a company called Deep Vision AI, which is a specialist in high-end vehicle recognition use cases and other use cases as well. So it's identifying the year, make, and model of the vehicles that are coming through. This can be important for understanding whether there's too many trucks on the streets that might be impacting traffic, or if you're actually looking to track whether you have more or less electric vehicles in your community year over year, and noting the increase in electric vehicle usage, or possibly even detecting autonomous vehicles that will be soon to be on our city streets. So that was just a quick view of what that sort of AI looks like. Interestingly enough, we have several cities that are starting to pilot these solutions using their existing traffic camera networks, feeding those camera streams into the artificial intelligence engine, and then determining what data and what alerts they want to see as a result of that. One of the cities I'm working with is specifically focused on Vision Zero and on reducing traffic accidents and fatalities. And some of the anomalies that they're asking us to try to detect through this AI are when things are abnormal, what's called anomaly detection, where a car is not where it should be, where a pedestrian may be in the street, where a bicycle is not in a bicycle lane, or where a car is in a bicycle lane, a vehicle making a wrong way turn at an intersection or running a stoplight. These are the sorts of things they want to capture. They want to understand where in the city, what intersections are the worst for certain types of anomalies, with an idea of trying to figure out how then leveraging that data to prevent them or reduce those incidents. The way it works is pretty simple. You've got your existing camera system. Most cities have these. In some cases, if they're deploying them, they can take advantage of some of the latest high definition video. The 4K cameras can do a lot more with video analytics than some of the older, less high resolution models. This is a team up between Dell Technologies and NVIDIA. NVIDIA providing the advanced video analytics cards called GPUs, or graphical processing units, that allow it to process a very, very large number of frames per second in high speed and generate that translation of video to data. Again, one of the partners we have in this space that we're working closely with for several cities is called Deep Vision AI. I'm going to give you some examples in this next section of what some of the projects that I've been working on and very closely working on, because I think it demonstrates what you can do if you have the right partnership between a city that's interested in innovation, in this case, the city of Las Vegas. You have various technology vendors that are interested in partnering with the city, and then what's called a public-private partnership to prove out capabilities, where the city is working closely with the vendor community to identify the problem, the solution, and how they can work together. Some of the initial use cases that were part of this project, and this was a partnership between a systems integrator called NTT, Dell Technologies, and then the city of Las Vegas, where initially we sat down and talked about various use cases that they hope to gain from deploying this sort of a solution: crowd counting and sound detection, wrong way vehicle movement, persons of interest, vehicles of interest, vehicle count for traffic and congestion. So this was all part of the initial pilot that was done about a year ago. Since then, they've actually purchased the system. They've expanded the number of venues that were being monitored by the solution, and they've even added use cases beyond these initial 4. Some of the use cases that were added just recently were related to COVID. They wanted to be able to detect where people were not wearing masks, where there was a gathering of people that were not observing social distancing, and they also added a thermal screening camera to detect people that had elevated temperatures. So the same sort of AI platform can be leveraged for adding use cases as needed. What it looks like is we picked a pilot area. Las Vegas has a place downtown called the Innovation District. It's right near City Hall, and it's right near a place called the Fremont Street Experience. And around that venue, our team placed 32 cameras, 25 license plate recognition, 7 crowd counting cameras, 5 gunshot audio analytics in crowded areas, 5 glass breaking audio analytics in traffic and parked car areas. So in this model, the approach was to deploy sensors. The idea is that these sensors, whether audio or video or other, we're going to be able to gather information and send it back to an actionable dashboard. So after the deployment, the city had a dashboard where I'll show you what it can work that would let them turn on or off different views to see what was happening, as well as be alerted to specific types of incidents as they occur. This is an incident where the city thought they had a problem with this intersection because it's a one-way street, and they had noticed several accidents at this intersection over the past few years. So they wanted to know how big the problem was that they had. So they set up this camera to detect when a car is turning the wrong way on a one-way street. They thought they had a problem of maybe 1 or 2 times a day, and they didn't realize that the problem was actually 10 to 15 times a day where a car would turn the wrong way, potentially causing an accident. So leveraging this information, they were able to say, okay, well, how do we fix that? We now know that it's a big problem. Let's spend some city resources. Let's get public works involved. Let's get traffic department involved and put some new signage up. So initially they put some one-way signage up, and they found after measuring what the change was, because now you have the ability to measure the effects of the change, they were able to reduce the incident number from 10 to 15 a day down to 8 to 10 a day, which is an improvement, but certainly not enough. So they went to the second step, and they put big one-way arrows in the street to see if that would then reduce the number of wrong-way turns, and it was far more effective. When they painted the big arrows as a second step, they were able to get it down to only 1 or 2 a day, and some days 0. So the ability to leverage this sort of solution to improve the city, hopefully reducing traffic accidents, reducing fatalities, is the sort of thing that these sorts of technologies can potentially provide. Vehicle recognition was also a very important part, as we saw in that other video. These can be a valuable thing for detecting both a license plate that might be a part of a criminal activity, but also potentially a year, make, and model. So if you have an alert and you're looking for a specific type of vehicle that may have been involved with an Amber Alert or other type of incident, you can quickly monitor this area and identify where all, say, red Mitsubishi Outlanders are within the monitored zone, and be able to feed that information back to those who would be searching for that type of vehicle. So license plate readers have been around for a long, long time. Most cities or many cities use them, but this takes that to a whole nother level of year, make, and model, and potentially even color as well, giving you the ability to do new things that couldn't be done before. Crowd counting was another very important use case for the city of Las Vegas. As we all know, Las Vegas is all about attracting a large number of people to a certain area, and hopefully having them both enjoy their experience as well as spend a lot of money in that area. So in this model, you're leveraging, again, a deep vision or computer vision AI to count the number of people in a certain venue. So in this case, it's able to accurately or reasonably accurately count how many people are in a given space, leveraging some of these advanced deep learning algorithms. The value of this is interesting because knowing how many people are in a certain area on a Tuesday afternoon versus a Saturday evening gives you the ability to leverage that data in new ways. So if you start thinking about machine learning algorithms, looking at data over time and then creating those predictive machine learning models, you can be pretty accurate in your machine learning algorithm as the system learns.
Do I have a picture? Yeah. Did you get my pictures?
I think so.
Oh, you said you couldn't. Okay.
Okay, not sure if that was directed at me or not, but happy to have you on the call.
Charlene.
So this, okay, hopefully we had the mute button was hit there, all good. So this is a model that shows how the red were the actual values of the number of people that were in this venue, and blue is the number of people predicted by the model. So this has 2 values to the city. The first one is understanding that if the camera is not in place, as it wasn't on certain days in May here, that you still have an estimate of who should be there or how many people might be there. The other thing it can do is tell you when there's a difference between a major difference between what is predicted and what is actually happening. So think, for example, of this venue having a particularly high number of people in it for a given Saturday night band. Maybe that band should be invited back more frequently because they're drawing a bigger crowd, which is important for tourism. But the other anomaly, which I think is interesting as well, is if you're monitoring a park, for example, and that park typically has maybe 5 to 10 people in it on a Tuesday afternoon, then on a certain Tuesday afternoon, there's 100 people in that park. The system will detect that as an anomaly and throw an alert back to the city to say, there's 100 people in this park, and normally there's only 5 to 10. Maybe it's an unsanctioned event, maybe it's a gang activity, maybe it's a gathering of people who should be social distancing. So the ability to then the city look at that alert, pull up that video clip, and identify whether the city needs to respond in some way to that anomaly, which has now been alerted by the city. The city believes this to be a force multiplier, meaning that instead of having to patrol that park every hour on a certain regular cycle, they can now only respond or only go to that park when needed and not as part of a regular patrol mode if they choose. Some of the metrics for this are very interesting, and this is over a 3-month period for most of this and over a 1-month period for the crowd counting. But you've got 4 million traffic counts, 1 million unique license plates, 433,000 crowd counts, which again came later. The most interesting fact is, although 65 terabytes of video and audio were generated by the system, only 2.6 gig of actionable data was stored. So this is essentially the translation of video and audio to those alerts, those car counts, those people counts. So you now have that as actionable data and not just the raw video. I'm going to take you through another project, which is with another customer I work very, very closely with. I'm located here in the San Francisco Bay Area. I've developed a great partnership with the city of San Jose on their innovative smart city strategy. For anyone who wants to move to San Jose, you'll notice that the median house income or median house price is very inexpensive, so it's easy to move there. Only $811,000 to buy a median house in San Jose, so they definitely have a affordable housing issue as well. The project that we worked on with San Jose was really around data lakes and analytics. Essentially, they called it the City Open Data Environment, or CODE, with an idea that they wanted to become a more data-driven city. They wanted to leverage data, and they wanted to analyze data in new ways. City leadership had bought in. The mayor was part of that smart city initiative. The city council was bought in. The city manager was bought in. And it was the CIO who worked with us to identify how the city could become more data-driven. So we put together a data lake architecture, highly adaptable is what he calls it. This is actually his slide that he lets me use. He calls it also IoT scale, leveraging tools like Hadoop, Hive, and Spark. Interestingly enough, one of the city's desires was for all open source software. So every software component that we put into this data architecture was something the city could use without having to buy expensive licenses for software, albeit there's some support implications with that, but as long as this wasn't being used in a mission critical mode and was mostly used for gathering new insights and gaining new insights, then the need for mission critical support was lessened. Some of the analytics that we started with were dashboards and data stories, they called them, and I'll show you some of those. And they also had certain target data lakes that they were looking at: disasters, crime, traffic, homelessness, housing. Some of these interesting and I would say very important pieces of information for a city to respond to. I'll show you some of the things we've done around traffic, and we're actually just starting to look at homelessness. There's actually a theory that with the current pandemic, that the number of people that are going to become homeless over the next couple of months is going to increase dramatically. So we're trying to look at how data can help us understand what those increases in homelessness might be. San Jose is very interested in it. Los Angeles is very interested in it. And we're actually working on a data analytics project related to homelessness as well. So as you look at a city that wants to become more data-driven and wants to develop a data-driven customer experience, there are certain ways they want to engage around data. They want to iterate around data in terms of understanding data better and leveraging the insights from that data better. And lastly, it's around empowerment, the ability to take action related to the data that they have, whether that's providing more information to the public through open data sites, through data visualizations, through their website, or whether it's things like housing bots or exception detection. So this is all part of becoming a data-driven city. Some of the first steps that we see, I would say government agencies taking, cities, counties, and state agencies, is to start looking at their data. The most common thing I hear when I meet with a city leader, CIO type or CTO type, is we have a lot of data, we're just not doing a lot with it. we have silos of data all over our organization, but we're not leveraging that data for insights or visualization. So an easy first step is to use out-of-the-box tools like Tableau or Microsoft Power BI. These are not advanced AI tools, but they are visualization tools that let you see trends over time. An example is you'll see this list of police incident types. In story number 1, here's all these different incident types that are on the increase and the decrease, and one that was dramatically decreasing between 2009 and 2012 was an incident called vehicle stop. And when you look at a trend that drops so dramatically, it makes you ask the question, okay, we see this trend in data. Why is this occurring? And you think, well, are drivers getting better? Are they making less wrong turns? The answer is actually not. This was during a recession, and the city had to lay off some of their police force. So when they had fewer police officers, they actually had to focus those police officers on other activities, and less officers were focused on traffic duty. So it's interesting to see how data can give insights. We also did some heat maps where we looked at incidents and when they're likely to occur. And I guess the heat map proves the theory that the hot spots within the city are Friday and Saturday night between 10 and 2, where you can see that that's a red indicator of the number of incidents reported. However, if you take it to the next level and you slice it and dice it by incident type, it paints a very different story. So although certain type of incidents were hot on Friday and Saturday nights, an incident like automobile theft was not typically reported on those times. The most common time an automobile theft would be reported is actually Monday through Friday, 8 a.m. and 4 p.m. Those were the peak periods for automobile theft reporting, which kind of makes some logical sense. You come out of your house or apartment for work and notice your car is missing, you report automobile theft, or you leave your work in the afternoon and again, your car is not there. So it's interesting to see how based on incident type, you can be more predictive in when these are likely to occur. I mentioned Vision Zero, and I mentioned the reduction of traffic incidents and fatalities as being a priority for most cities around the country. This is an example of identifying top intersections, both those that have the most accidents, as well as those that have the most fatalities per accident. So which are the most dangerous intersections in the city. Interestingly enough, again, slicing and dicing the data gives you different insights. For example, where is an intersection particularly a problem for vehicle to bicycle incidents, vehicle to vehicle incidents, or vehicle to pedestrian incidents? And some of our initial analysis has determined that the highest percentage of fatalities is actually related to vehicle to pedestrian incidents. So of all the incidents, that's the type that we're now focusing on to figure out how we can reduce the number of vehicle to pedestrian incidents. Getting into sort of the more advanced levels of machine learning and AI, you start with descriptive, what is happening. You move toward those predictive models that I talk about, what is likely to happen. And then prescriptive, meaning what are you going to do to prevent it or change it or respond to it. And then the highest level being cognitive, where the system continues learning and continues refining those models to make them even better. So here's an example of a descriptive analytic, the number and severity of traffic accidents over the past 6 months. This is merely a description of what has happened over 6 months. And this data set actually gets even more valuable for some of the other use cases, the longer the data time that you have. So if you end up with 5 years worth of data, it's even better for those predictive models than just 6 months worth of data. So using a machine learning algorithm and our artificial intelligence algorithm, you can start to become more predictive around where incidents and accidents are likely to occur. So this is a great use case for how, again, these more advanced AIs can help the city to be more proactive. So if we believe that we have a 71% chance or an 82% chance that we're going to have an incident at this intersection based on 5 years worth of data, and we might even know that the incident is most likely to occur during morning rush hour or afternoon rush hour because that's what the data shows, then maybe the city can change a little bit, or maybe be proactive. Given this new information, given these new insights, could the city then be deploying potentially emergency vehicles or ambulances or other things in anticipation that an incident is likely to occur? Or can they also make changes to that intersection so that the number of incidents is improved? And then lastly, looking at the cognitive type analytics, which is the highest end of the scale, It's around continuously learning to refine and become better and better at predicting these things. Adding other data sets to the data model can help you with improved accuracy around whether it was precipitation, sunrise location, average travel speed, the day before a holiday or the day after a holiday. All these other pieces of information, when added to that machine learning module, can help you to be an even better predictive model, knowing that in the winter, the sun rises in people's eyes, so you're more likely to have incidents in the winter versus the summer. This particular intersection is very, very bad when it's raining. So some of these things can, again, provide new insights that the city didn't have before. A general strategy that we see, and this is sort of changing subject slightly, is around data and about how data is typically siloed within a government environment. You have water data, you have mobility data, you have waste data, health services data, police data, and when you start to think about how you could connect data, breaking down silos between these siloed independent data stores, and then starting leveraging both data integration as well as data aggregation, that's how you start getting towards that smarter ecosystem. And the term that we often hear in this space is a system of systems, where if a system is operating on its own, that's great. Maybe you have a smart water initiative or a smart garbage initiative, but when those things are combined into a comprehensive data strategy, you end up with a greater benefit to the city and to the constituents within the city. A good example of this is a small city out in Florida that has looked at data integration, data aggregation as a key part of their strategy. The city is called Doral in Florida, relatively small, but a community that was willing to take that step to say, we're going to embrace smart city, we're going to embrace digital data standards, we're going to adopt some of these data standards that are global, like the World Council on City Data, and we're going to start looking at how data can change the way we operate, both from actionable intelligence. And if you ever go to Doral, Florida, it's a great place. I've been there a few times, know the CIO pretty well. But then it comes to digital transformation of citizen services using IoT and connected technologies like we discussed before. And then, of course, digital civic innovation. I bring this up because a lot of people think that smart city is just for the largest cities, whether it's Los Angeles or Chicago or New York. And what we're seeing is some of the smaller cities are able to innovate and move more rapidly with the desire to both improve the city environment, but also with an eye towards economic growth, as I mentioned before. By putting out a plan like this, by highlighting some of the successes that they've had, they become perceived as technology leading cities. And again, both benefiting the community as well as attracting the right ecosystem of businesses to that environment. As we evolve the smart city space, I will say that the best way to start is to solve a problem. Some of the larger cities have problems with traffic or crime or environmental sustainability. Some of the smaller rural cities might have problems with dumping in rural areas or providing connectivity out to disconnected communities. So as you start looking at a strategy in this space, solving the problem is usually the best place to start. And believe me, cities have no shortage of problems to solve, and they're often looking for how technology can help them get to that better state. Lastly, and I'm on my last few slides because you can only take about 40 minutes of my voice before you start to tune out and go to sleep. We would like to approach this as a strategic approach. So instead of doing a one-off for police or a one-off for water, you're looking at it as a strategic approach, leveraging the same, I would say, smart city infrastructure and technology stack for addressing multiple use cases across the city. So those cities that embrace this sort of holistic approach when it comes to data integration, data aggregation, connected devices, and analytics are seeing the more beneficial outcomes. So again, it's not an individual silo, it's a strategy, and it's the city buying into digital transformation as a whole. Another thing I'm going to end with, and before we turn it over to discussion and Q&A, it is a partnership. We are very fortunate that Dell Technologies is a established vendor partner with many of the cities and counties and state agencies that we work with. So it's not about selling the latest technology from our portfolio. It's more about how we can work together to solve real problems. We take that very seriously in terms of how we approach this. It is a strategic partnership and not a vendor-customer relationship. Hopefully some of you on the call have seen some things that may be of interest. I will offer that I am responsive to folks that want to learn more, that want to engage in further dialogue. And I would say I'm happy to travel out to Arizona as soon as the shelter in place is lifted. So with that, I'm going to stop sharing, and I'm going to maybe turn it over for some discussion and Q&A, any feedback that you might have or any questions that might come up.
Don't hesitate to just unmute and ask your question. No need. Don't be shy.
And if you don't like hearing the sound of your voice, you can use the chat window.
That's fair, and I'll read it.
Yeah, I can now see it because I stopped sharing.
Mark Goldstein, good afternoon. Great presentation. Two things. One, a comment. $800,000 medium house crosses the affordability threshold. It may be affordable in San Jose, but it's probably 3 or 4 times the median cost here. That aside, I was interested in getting your take on some privacy matters about collection of license plates these days, especially about facial recognition and the balance between smart city goals and personal privacy protection. Thank you.
Very good comment and very good question. Obviously, there was some humor involved in the pricing in San Jose. It's actually a pretty big problem for them and a challenge for people to find affordable housing. There's a lot of Silicon Valley workers that can't afford to live anywhere near where they work, so they commute long distances to get to their jobs. So it is a challenge for them as opposed to a benefit. The privacy one is an interesting one because it's more about policy than it is about technology. So in some cases, cities or counties are banning facial recognition. It's very prominent here in California and some other states to ban those technologies. It's also become sort of a national issue as well recently. So I think many cities who have either haven't established policy yet about what they're going to do to protect personal privacy are soon to do so. And the technologies can conform to whatever that policy is. If the policy says this is going to be used as an optical sensor only, we're not going to store the video, we're going to blur the faces, we're going to ensure privacy. Some of those policies are just as easy to implement as those that can do those more advanced capabilities to identify people in vehicles and license plate readers. So I'm not deferring to the answer. The answer is really, what is the policy of that city and its community? And it varies very widely across the country. You have some cities here in California that are fiercely protective of their public privacy and won't allow their city to record any video, which is where the concept of an optical sensor with blurred facial recognition or blurred faces is more palatable. You have other cities that seem to be perfectly fine with more invasive privacy measures, such as I would say the most advanced one is obviously the London and in some cases New York, where the public is okay having some of these technologies deployed that are a little more invasive. But it's again, more of a policy issue. Good question, thank you.
Yeah, I had a couple comments and a couple questions because I actually grew up in Las Vegas, so I'm intimately familiar with the area of town that you're describing. We got married at City Hall. I know exactly where it is. I know the mall in the pictures you were showing. There's an outdoor mall there, and I know that intersection very well. What's more interesting to me from being a resident of Las Vegas, I grew up my whole life there till I was 33. What's very interesting is how do you'd have to have concurrent data with or how do you mesh the thousands, tens of thousands of cameras from the casinos with the publicly accessible public space cameras, because those are two very different systems.
Yeah.
So I guess one of my questions did the casinos play nice with these ideas?
Mhm.
Because when you say Las Vegas, and just for those who aren't aware, Las Vegas is a specific city, and the strip itself is not actually in Las Vegas, which is a
That's
lot of people
correct.
don't realize. And so I just wanted to clarify, are you talking about Las Vegas, the general metropolitan area, as we would say Phoenix, which would include Mesa, Gilbert, Tempe, etc., or are you just talking about the actual city of Las Vegas, which is a much smaller footprint?
It's the actual city of Las Vegas is where this system is deployed. And with regards to any feeds from casinos, that was something that was considered but has not yet been requested or responded to. The city is also very concerned about privacy. As we work with them, they didn't want to be on the front page of the newspaper saying your city is invading your privacy. So I don't know if you saw, but on some of the videos that I showed, there was blurring going on. These are actually high definition cameras that are choosing to record at a much blurred level. The feed that goes into the analytic is the high definition, but the feed that's actually recorded temporarily and not kept for very long is a blurred image. So they are conscientious of privacy. And it's also interesting because in Las Vegas, every casino you go into or every venue you go into has recording going on. So you'd think people would be far more accepting of that technology given the amount of monitoring that happens in casinos, but the city is still very concerned. And so they've adopted a protection of privacy viewpoint. One other related story, which I found interesting, is that we tested facial recognition in the concept of a lost child use case. So if we have a lost child in this venue, could the system find that lost child? And the answer is absolutely. It could find that lost child very, very rapidly. The city has still not chosen to turn on any of that capability because of their concerns about privacy, but they do have the capability if there was an emergency or if there was a child that they wanted to see if they could find, they could use that tool if they chose.
Have they gone any further? This is just, I'm just thinking future, thinking ahead a little bit. So for the military and other groups, they use IFF, identify friendly or foe, markers when they're in the field. I wonder within the context of this arena, if something similar could be employed of especially IFF tags to differentiate employees versus customers, so that you can, instead of having to use facial recognition, it could be done through RFID and different sensors, so that you can identify, very similar to, I believe it's Norway or Sweden that is actually doing the employee chips implanted into, so biometric chips implanted into people's hands in place of an RFID card. So these are the sort of things, which is an even higher level of invasiveness, literal invasiveness into the body. But these are the sort of things I know are considered.
Two responses to that. One is if you do want to train the system on identifying employees, for example, that could be easy for it to do. So an employee can get into a certain restricted area and a non-employee can't. So those are use cases that can be implemented. We did do a test case around persons of interest without facial recognition. So one of the use cases is if we have someone come into a venue and we later identified that that person was involved in some sort of a criminal activity, and we want to go back and have the system trace where that person went, we can actually do it without using any facial recognition activity. It's based on height, clothing, the way the person walks, the way the person acts. So it's not using facial recognition, but it gives you the ability to track that person through the venue. I don't know if that answered your question, but I thought it was pretty advanced.
No, it does. Well,
I got a little question
and
that's on a different
go ahead.
track. Oh, sorry. My question is kind of twofold. It has to do with your thoughts in the autonomous vehicle space and how that relates to smart cities, and maybe if there's ever going to be any standards there. We have a lot of competing technologies, right, with the Waymos, and everybody talks about Tesla's gathering more data right now than anybody on the planet because they just had so many cars on the road for so long. And then the other one, which is kind of an umbrella to everything, is the whole ethics of AI, right? So I'm Kurt Bush of Big Data Southwest, and I also co-chair the Arizona Technology Council IoT and Smart City Committee with one of my Intel colleagues. And that's becoming quite an issue, right? Is the whole ethics of AI. It's all interrelated. So I'd be interested to hear your comments on that.
Okay, let me see. Ethics was first, and then you'll have to remind me what the next one was. Understand the issues and concerns that AI can be used for various purposes, some that the public would be happy with and some that the public would not. It's obviously a very controversial subject right now within our nation. But if you look at AI for good and you start focusing on those use cases, which is primarily what we've done with the cities we're working with, if you're using an AI to reduce traffic fatalities, I don't think the public's going to have an issue with having fewer accidents, fewer fatalities in their city. So I agree that the ethical angle is a concern, and it's an even heightened concern in recent times. So again, I'll defer back to the city policy on that one. And I think there was another question you asked that I didn't remember because
the autonomous vehicle,
autonomous vehicle.
Emerging technology and that whole thing.
Yeah, I do have a take on that. They are coming. They are getting better and better, and I believe that those cities that have already passed policies to allow them to operate in the city, right now most of them are operating with a driver that is sitting there not touching anything because that was required by the policy. I know of some cities in Arizona that take a leadership position there. They also are Las Vegas has done some autonomous vehicle piloting. Where I see this headed, which is very interesting to me, is on infrastructure supporting autonomous vehicles. So an autonomous vehicle does a very good job of reacting to its environment, understanding its environment, and making the right decisions based on what it's been taught to do. However, an autonomous vehicle operates even better when it communicates with connected infrastructure. So some of the leading cities that are looking at connected infrastructure, the ability to have the autonomous vehicle communicating with the street, with the street light, with other vehicles, and providing that more broad scale view to that autonomous vehicle, it actually improves the ability of the vehicle to operate. So there's been some very recent initiatives around connected autonomous transportation infrastructure for some states that have taken the lead in that. And there's some testing already started about the infrastructure, both on the state's highways as well as within communities where an autonomous vehicle can send and receive data to a relay service that will be operated by the government agency. It's an interesting space, very much. Think about it in terms of this. Let's say you have autonomous trucking. So now you have trucking where a truck can be loaded and it can take that truck, across several states without a single driver in it. Probably not good for the truck driving community, but the ability to have that truck communicating with that infrastructure along the way makes it a far more valuable, I would say, or far safer and more efficient system. I don't know if that helped or not, but that's my take.
No, that was wonderful. Thank you very much.
Welcome.
This is Timothy. I'm curious, kind of as a follow-on there. Have there been any autonomous vehicle projects that you found exceptional or that stick out more than others, or any that just get you really excited about the prospect of the technology or the value?
I think, how to answer that question? Great question. I guess you have to give it a thought for a minute. I think the vision that some of us have seen about where autonomous vehicles can go is when you see that intersection of the cars that are essentially weaving themselves through the intersection and knowing where the other car is, so there's never a need for a stoplight because they can weave in between each other at high speeds. I think some of that technology is a little far from being implemented, but that's some vision of the future. And if you had that vision, actually human drivers would become nearly impossible for that sort of connected autonomous vehicle movement because the human driver wouldn't be able to do those sorts of things that the autonomous vehicle could do. What else sticks out? I would say that some of the connectivity things that are starting around connected infrastructure, are very, very new. And again, I'm involved with a project around connectivity infrastructure that's rolling out 5G across roadways to make it a smart roadway, and being able to then have those interactions between the infrastructure and the vehicle. So those are all sort of the cutting edge spaces.
Thank you.
And I know we're reaching the top of the hour, and I know we had planned for a little longer, so we can either wrap it up in a few minutes or we can go longer. I'm excited that we had such a great turnout today, and hopefully there'll be some follow-up discussions. I'm going to continue to attend these. I hope you don't mind, because I find them very interesting. I looked at the speakers that have been up in the past and those that are upcoming, and I welcome the opportunity to join this group if I'm allowed.
There are a couple of questions posted in the chat that haven't been
Okay.
addressed.
All righty.
And Mark, sorry, Mark. Mark, do you want to just ask them as opposed to the chat?
Well, can Rob read those himself?
Well, there's a request for the presentation deck, and I would say yes, but I want to make sure that it was shared with folks that may not be competitors to Dell in this space. It's the first one, because we're all out there trying to position to be the go-to person in this space. And the other one is that I usually ask permission from the customers that I work closely with, so they don't feel that I violated any trust in sharing a deck that I should not have.
And Rob, we appreciate and value that, here. I think that, it's, we understand that, if there's elements of the presentation that, you feel, hey, this is something that, we need to, we can share, this is something we can't, and that's okay. We understand.
Okay. I will review and respond to that.
Looks like there was a question from Dan. Hey, Dan, it's good to see you on the line. Want to invite you to ask your question since you're on the call, and I know you personally.
Yeah, I was just trying to minimize the dog barking and all that, but I think we got a little moment here. So, thinking about big data, thinking about data lakes and all these tools that gather just terabytes of data, how is that analytics being performed across that, especially if we're looking for threats in just obscure ways and trying to get that information through partnerships that maybe already exist, like SecureWorks?
Well, thank you for mentioning SecureWorks. It's a Dell company, so thank you very much. But I would say the data analytics strategy, whether you're using a data lake approach or whether you're using a off-the-shelf product, is really the capability of analyzing very, very large data sets, as well as linking data sets together that can derive better intelligence with the view across those data sets. So a data lake is one way to do it. There are others leveraging other tool sets in that space from other vendors. But the core capability of analyzing data is coming down to the ability to effectively, I would say, back end that data with a processing engine that can handle that scale, as well as what tools you're going to use on the front end, whether that's going to be data science tools like programming in R, or a tool that I particularly like called Data Robot, or some other tools and technologies. It's the ability to define the model, ask the right questions of your data, and then have a back-end system that can actually process through all that data. Again, a data lake and a Hadoop-based architecture has been proven for a while, but there's some new technologies out there from other vendors that may even be better.
Yeah, I was just thinking along the lines of, we're talking about smart cities and, identifying pedestrians that are coming up to the roadway and just these like various scenarios. That's got to be processed and through some type of an engine someplace. So how do we take advantage of that smart city type engine that's already in place and start using it for other data types?
That's a good question. Let me answer it in a different way than maybe you had intended. What we're seeing is a move more from a centralized architecture around IoT to a distributed architecture. The idea that every sensor has to flow its data back to a central processing area for processing is now moving towards what's called fog computing, as opposed to cloud or data center computing, where we're moving those analytics closer to where those sensors exist. So if you think about monitoring a park, for example, or an intersection, you have multiple sensors around that park. Why not move the processing power to what's called a micro data center at or near that location? So those streams of audio, video, or whatever sensor data are actually processed close to the source. And then the only thing coming back across the wire is not 10 streams of high definition video, which becomes a network bandwidth issue, but only the resulting data, alerts, and clips of any incidents that were captured. I don't know if it answers your question, but that's definitely a trend that is growing right now.
Yeah, no, that's perfect. And then I would imagine that we could get a subset of that, like metadata, you know, on the important stuff that we could pull back to a central location to do that analytics on a bigger scale.
Correct. So it's the real-time data processed at the edge, the aggregated data that's being aggregated centrally for those, again, machine learning predictive models.
Perfect. Thank you.
My question might even be a plug for Dell. How is your smart city group working with your other groups inside of Dell, let's say in the appliance and server business, the storage business, and then the data center side of things? I mean, is Dell a big cloud player with the Amazon Web Services and the Oracles and the Googles and the Microsoft Azures? Or are you guys going to start rolling out a bunch of, you know, micro data centers at the edge? Because that's going to be obviously a huge trend. I mean, David Cody just bought Vertiv for that very reason. And you know, I'm an old Motorola machinist, so I'm always the dumbest guy in the room, so I apologize for my questions. And now we've got another, well, we have another buzzword with this fog thing. I'm still trying to get my head around the clouds and edge, and now we have fog, and I can relate to that. I'm kind of foggy. I feel good about that.
No, I think you asked a great question, and I think the strategy that we come back with as an organization is that it has to be end to end. You have your edge environment, you have your core data center, and you have your cloud, and you have to use that in the most intelligent way. There are certain things that need to be are best processed at the edge. There are certain things that make more sense to aggregate in your data center. And then there's certain use cases and there's certain data sets that are probably better in the cloud. So as you approach this, you have to understand, where is that data going to be stored? Where is it going to be analyzed? And what's the best for either the cost model, what's less expensive, or where the analytic will perform the best, whether that's, you know, aggregated in the cloud or the data center. One of the big parts of our strategy is something called Dell Technologies Cloud. And I'm not going to talk product here because that's not a good thing. But essentially, it's an abstraction and portability layer that lets you move workloads both to an edge device, to the data center, and to the cloud. And it leverages public cloud providers like AWS, Azure, Google, and others. So we have those links built in, and we allow our customers to move workloads around very seamlessly. What we try to avoid is the cloud lock-in that many people have experienced when they build an application or a workload on a specific cloud, and the tool sets in that cloud, they're then locked into that cloud. And part of our strategy is to say, don't do that. Have this abstraction layer so you can move things around easily, because there might be a cheaper way to move it either from cloud A to cloud B or back on-prem if the cloud provider suddenly raises your rates dramatically. So that's our strategy in that space. And thank you for asking that question, because it's a big part of our go-forward strategy as well. Any other questions? Somebody owes me a drink. I like that.
I think we are. I think we're at the end there, Rob. I think that was it for a question.
All right. Cool. I know it's. Sorry, go ahead.
I just wanted to say thank you for joining us, Rob. I mean, you know, this was a really engaging session. I was excited by the questions. I was excited to see some of the video. So yeah, no, thank you so much. And maybe, I don't know, just if you wanted to share a closing remark here for the group.
Closing remark, thank you for inviting me. I always enjoy sharing things around innovation. So if you'll have me, I'll be a member of your community going forward, and I look forward to being on site with you all one day at a brew pub.
Thank you so much, guys. Thank you, everyone. This is fantastic. We really appreciate you joining us. And feel free to join us for the next Innov8. And Rob will be looking for you there, man. Thank you.
And Tim, thank you very much. Tim and Aaron both. Great job arranging all this. Thank you.
No,
Yeah,
thank you.
Thank you.
Ponch is very
Great
proud,
session,
I'm
guys.
sure, even though we're bummed Ponch is leaving. I'm not happy with Ponch's new job. Just being selfish.
Pretty amazing, though. Pretty amazing to have
I know
ASU
it's
men
amazing,
going in
and
there.
he's
It's pretty
amazing,
cool,
but I'm selfish.
it's always sad to lose those amazing folks, right?
I know, isn't he amazing? I'm gonna miss Ponch.
Yeah. Thanks so much, everybody.
Thank
Thank
you.
you.
Session.